This is RD Sharma solution class 12. We are taking probability and the exercise is the third exercise. Two dice are thrown and it is known that the first die shows a 6. Find the probability that the sum of the numbers shown on two dice is 7. Now in a die you know that is 1 to 6. There are two dice. So 36 is the sample space. Let's make the event. So the A event is first die shows a 6. So first die will always show a 6. Then the next event will be the sum of the numbers in the two dice. When we add them, that should be equal to 7 or that will come as 7. So this A event will be like this. We are fixing this 6 as the first outcome. So 6-1, 6-2, 6-3, 6-4, 6-5 and 6-6 can come. So this is A set. Now coming to the set B, sum should be 7. So now this whole line which you see here, just take the row and column die number, they will give you 7. Only in a set you have to be careful that the same entry is not allowed multiple times. So 2-5 and 5-2 both are 7. Similarly 4-3 and 3-4, if you add them, they will also give you 7. Then 1-6 and 6-1. Again, add them, you will get a 7. So number of elements in A is what? 1, 2, 3, 4, 5, 6. It is 6. Number of element in A is 6. Number of elements in B, so it's 5. 6. 1, 2, 3, 4, 5, 6. Now let's take the A intersection B. What are the common values? Or what are the elements in both the sets which are common? So this 6-1 and 6-1 are common. Only this 6-1 is the only common value between NA and this PA and PB or the set A and B. So the NA intersection B, that is the number of element in A intersection B is 1. So the probability of two dice are thrown, if it is known always comes below. So we have A in the below part. The sum of the numbers showing two dice is 7 is B. So PB by A will be PA intersection B or PB intersection A divided by PA. Just change it to N because we are dealing with the numbers. This will be 1 and NA actually. It's 6. So 1 by 6 it is. So this is how you are going to go about it. A pair of dice is thrown. Let E be the event that the sum is greater than or equal to 10. And F is the event phi appears on the first die. Find PE by F. Now if F changes to an event, F appears on at least one die. Find PE by F. So we have to have E, F, then EF. E remains the same, but F changes. So it's basically two questions in one question. So we'll deal it with like that only. So let's make the events first. E. Since F, F are similar in the question, so we'll just differentiate using as a F1 or F2. So E is the event that sum is greater than or equal to 10. So I'm writing it. You have to write it completely. So sum must be 10 or 10 plus. 10, 11, 12. So the highest number can come as 12 only because most highest number is 6 only. 6 plus 6 is 12. Now making the first F, phi appears on first die. So E will be what? Sum is 10 or higher. So what it can be? 4, 6 is 10. 6, 4 is 10. 5 by 5 is also 10. 5, 6, 6, 5. They both are 11. Then 6, 6. So if you see all these numbers, two numbers, if you add, it will be either 10 or higher. So the first F event is phi appear on the first die. Let's call it as F1 and F2 just to differentiate that these two are separate questions and we are dealing with them one by one. So this F1 and F2 I am just renaming to explain you. First F, that is F1, comes as phi appears on the first die. So the first number 5 is fixed. The second can be 1 or 2, 3, 4, 5 and 6. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6. All these can come. Now coming to F2, which is the second F, phi appears at least on one die. So you can fix the first number as 5 and then the second number as 5. So 5, 1, 5, 2, 5, 3, 5, 4, 5, 5 and 5, 6 can come. Then the 5 can come in the second die also. So 5, 5, 5, 5, 5. I am writing 6 here, means 6 times 5. But there will be a catch. I'll just tell you what is the catch. 1, 5, 2, 5, 3, 5, 4, 5, 5, 5 and then 6, 5 also. So in all there are 12 entries here. But if you see 5, 5 is repeated here. You need to be very careful about the brackets because the set has to be represented. The same values are not allowed. So this 5, 5 you can eliminate. One of the 5, 5 you can eliminate. Just keep one 5, 5. So in all there will be 11 entries here. How many entries in F1? Which is 6. How many elements in E? 6. Now probability can be computed, but before that we need to have the intersection values. So E intersection F1 and E intersection F2. So there are two separate questions as I was suggesting. So I'll do it in front of you only on the same screen, but assume that they are different because the question wants you to do it separately. Now the intersection of E and F1. So we have 5, 5 first, then we have a 5, 6. So number of elements in E intersection F1 is 2 now. Now E intersection with the second F, which is F2. So what are the elements which are common in both these? So 5, 5 again, we got it. Then 5, 6, then 6, 5. 5 will be everywhere. Now what is the number of elements in E intersection F2, which is 3. Now taking the probability formula is simply E by F. This is P E intersection F divided by PF. So first I am taking P E by F, which is I am calling it as F1. Second one is P E by F2. I am calling it as F2. They are F only in the question, but I am just suggesting F1 and F2. So number of elements in E intersection F1 is 2. From here I have taken. The number of elements in F1, we have already computed that. So it's 6. So 2 by 6 it is. Now here number of elements in F2 is 11. And intersection gives you what? E intersection F2 is 3. So we have 1 by 3 and 3 by 11 as the answer of 2 parts. So this is you have to do first. The E remains the same. F changes and accordingly the results also changes. Intersection also changes. So I hope you got the idea. This is how you're going to go about it. So these are two cases and separately you have to do it. The probability that the student selected at random from a class will pass in mathematics is 4 by 5. Now if you select them in random, any of these students, it will pass in mathematics. The probability is 4 by 5. And the probability that he or she passes in mathematics and computer science both, and means it's an intersection. That is, the student has to pass both in mathematics and computer science together. What is the probability that he or she will pass in computer science if it is known that he or she has passed in mathematics? Now if we assume or we know that he or she has passed in mathematics, what is the probability of he or she being passed in computer science? So let's call it M and C. M for mathematics and C for computer science. So M is what? So passing in mathematics. C is mathematics and computer science passing. This is, we are calling it as C. So C is actually mathematics and computer science both. The probability of maths is 4 by 5 given. Probability of math intersection computer science is half. So probability of mathematics is known. What is the computer science formula? So it is P C intersection M divided by PM. C intersection M is half divided by 4 by 5. Let me just check. C is only the computer science, okay? So I'm changing my statement now. So the final answer is 5 by 8. Let me show you also. M is mathematics and C is computer science. The probability that certain person will buy a shirt is 0.2. Let's make it like this. S for shirt and T for trouser. So probability of a shirt that certain person is going to buy a shirt is 0.2. Now the probability that he will buy a trouser is 0.3. So PT, I am representing the probability of trouser. The probability that he will buy a shirt given that he buys a trouser. The probability of, see, it's a conditional probability. So what is known goes below. So this trouser is being brought, but what is the probability of buying a shirt after buying a trouser is 0.4 given in the question. What is the probability that he will buy both shirt and trouser? So P shirt intersection T needs to be found out. This is the first part. Second part we are just going to take, but let's solve the first part. PS by T is PS intersection T divided by PT. So this whole PS intersection T will be PS by T multiplied by PT. We are just cross multiplying it. And now we have both the values. PS by T is already given in the question, which is 0.4 and PT is 0.3. So 0.4 into 0.3 is 0.12. How about the second part? Find the probability that he will buy a trouser given that he buys a shirt. So it's just the inverse of PS by T, which is PT by S. So when shirt is known to be bought, what is the probability of buying trouser? This is PT intersection S divided by the probability of S. So T intersection S or S is intersection T we have already computed. This is 0.12. The probability of S is 0.2. So 0.2 here. So it will give you 0.6. This is your probability. So both the probability has been computed now. So whenever you are writing it, this is how you are going to write it or solve it. In a school, there are 1000 students, out of which 430 are girls. If it is known that out of 430, 10% of the girls study in class 12th, what is the probability that a student chosen randomly studies in class 12? So random it can be a girl, it can be a boy. So what is the probability that the student chosen randomly studies in class 12, given that the chosen student is a girl? So before we go ahead, let's diagrammatically understand what is the scenario in front of us. In a school, there are 1000 in all students. In this 1000 students, there are boys and girls. 430 girls are being told are present or exist in the list. 570 are the boys. We don't have to worry about the boys because the question is all about the girl probability. Now the second thing which is being told is out of these 430 girls in all, 10% of the girls study in class 12. So from 1st to 12th class, there are in all total 430 girls, and 10% of these 430, they are studying in class 12. So 430 into 10 by 100, that is, I am taking the 10%, that comes out to be 43. So 43 girls are present in class 12 or enrolled in class 12. So what is the probability that a student chosen randomly studies in class 12, given that the chosen student is a girl? So there will be two events that we are going to make. One event will be that it is known that chosen student is a girl. So student is a girl is one event, and student chosen randomly studies in class 12 is the second set we are going to make. So let's start with S, student chosen randomly. Again, I'm saying it can be a girl, it can be a boy. So student chosen randomly studying in class 12. So first, it is known that it is a girl. So we are making G now. So G can be student is a girl. This G is student is a girl. So S by G. This is a conditional probability. So that's how S by G will be computed. Alright. So we'll just solve this question by our basic probability definition. This P S by G is PS intersection G divided by PG. Now what is PG? Probability of a girl. Now in all there are 430 girls and there are total 1000 students. So 430 by 1000 is the PG. So choosing a girl randomly from 430 girls. So this only girl will come up is 430 by 1000. Now what is this PS intersection G? Now a girl chosen and also the girl belongs to class 12. What is that probability? That is S intersection G we are finding out. That is in all there are 1000 students. But what is our favorable cases? Total number of cases is 1000. What is our favorable cases? 10% girls are in 12th class. So this will be 43 by 1000. So PS intersection G is 43 by 1000, which is the girl, and girl also in class 12 is 43 by 1000. And then choosing a girl from all the 1000s, which is the PG, that having a girl from 1000 possibilities. So in all it will be 430 divided by 1000. So when you divide them, it will be 1 by 10. The required probability is 1 by 10. Now how this will be done? This is how you are going to go about it. Alright, it's a tricky question, but you will understand it. 10 cards numbered 1 to 10 are placed in box, mixed up thoroughly, and then one card is drawn randomly. So let's make the sample space. Sample space is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 cards in all, mixed up thoroughly, then one card is drawn randomly. If it is known that the number on the drawn card is more than 3, what is the probability that it is an even number? So it is from 4 to 10. If it is known that the number on the card is more than 3, it is already known that the number on the card is from 4 to 10. What is the probability that it is an even number? So we'll make two different event. A is even numbers on the card. It can be 2, 4, 6, 8, 10. So A said, let's make it like this. So it will be, we are talking about even numbers on the card. So 1 to 10, 2, 4, 6, 8, 10 are the even numbers on the card. Number of elements in A is how many? 5. Now B said we are making number which appears is more than 3. So more than 3 on the card means it has to be from 4 to 10. So the set becomes like this. 3 is not inclusive. More than 3 means you have to start with 4. 4, 5, 6, 7, 8, 9 and 10. So number of elements in B is how many? So these are in all 7. Now we have to find out the intersection here. A intersection B. How many values are common in both the sets or found in both the sets? It will be 4, 6, 8 and 10. So number of elements in A intersection B is 4. Now probability of A by B. That is how we made these events and sets. That is, we are aware that the number on the card is more than 3, which is set B. What is the probability that is an even number, which is set A? A by B is PA intersection B divided by PB. Let's make it N because we are dealing with numbers. This will be 4. A intersection B is 4 and 7 is the denominator and B, which is 4 by 7 is the answer. So this is a very straightforward question. I hope you'll be able to do it by yourself only because this question has been taken in the previous discussion also. Assume that each child born is equally likely to be a boy or a girl. So again, this question is also being done, similar question, but those who have not understood or want some recall. So equally likely means 50% chances of girl or boy being born is possible. If the family has 2 children, so 2 children are there, what is the conditional probability that both are girls given that? So this is given, conditional probability. The youngest is a girl, at least one is a girl. So let's make the sample space. See, 2 kids means both can be boys. First boy, second boy. Then we have both the girls, G1, G2. 1 boy, 1 girl, or 1 girl, 1 boy. So this is in all the total sample space. Sample space, let's write it in a formal way. Same thing I'm writing formally here. It will be B1, B2, B1, G2, G1, B2, and G1, G2. Same thing we have done here. Now let's make A here. We'll make this as B and C because you know that the thing which are known goes in the below. So B, we are making the youngest is a girl. So I'm just writing in short. You already know it is given. The question is noticeable also here. So the youngest is a girl is B and at least one is a girl. At least one is a girl because we want A by B and A by C. That's why I have taken B and C as these two. Now what is the conditional probability that both are girls? So A we are interested in which are both the girls. Both are girls. That's why we made it as set A. Now let's make A. We are making the set both are girls. So G1, G2. Then B. B is youngest is a girl. Means the second child should be a girl. So G2, G2 should be there. So where all we have G2, G2. So G1, G2 and B1, G2 is a possibility. So I'm taking it actually from the sample space only. So B1, G2 and G1, G2. C is what? C is at least one is a girl. At least one is a girl. So the only total boy is can be ignored. Others can be taken. So B1, G2, G1, B2 and G1, G2. So all these 3 have at least one girl. Number of elements in A is what? 1. Number of elements in B is 2. Number of elements in C is 3. Now PA by B we will find out and PA by C. That is both are girls. If it is given that youngest is a girl is PA by B. And both are girls if at least one is a girl is PA by C. It will be PA intersection B by PB, PA by B. And PA by C is P intersection C by PC. Now A intersection B, let's find out first. A intersection B, what is the common values? Only G1, G2 which we find is the common value. So let's write it as G1, G2. So number of elements in A intersection B is only 1, G1, G2. So let's write it as 1. Now A intersection C. A and C when you intersect, again G1, G2 because A has only G1, G2. So G1, G2 again. So this is again 1. Number of elements in A intersection C is 1 only. Now put it here in the question. P intersection B is 1. P intersection C is 1. What is PB, which is number of elements in B? So I'm just making it as N. Number of elements in B, we have already computed that. It's 2. Number of elements in C, which is 3. So 1 by 3. 1 by 2 and 1 by 3 are the respective probabilities. Now whatever we have discussed is given here. You can follow this. Okay. So this is all about this discussion. Thank you so much and have a good one.